Bhaiya, what are you doing? I'm making my digital nameplate, Shivansh. Okay, I have a problem. Tell me, what is the problem, Shivansh? My problem is, how can we measure long distance without a measuring tape? Oh, so you want to measure distances which are longer than a measuring tape? Yes. Okay, I need to think about it. It's a very difficult problem. Okay. Hello. As you can see on my digital nameplate, my name is Shivansh Gupta. I am 10 years old and I am a student of grade 5 at Samhita Academy, Bangalore. This is my submission for the Sci-Fi Innovation Challenge organized by Sci-Fi Labs. My experience with Sci-Fi Labs was very good. Especially my teacher Riya ma'am, who explained every concept to me very nicely and solved all my doubts. As they saw my discussion with my brother, the problem I'm trying to solve is how to measure long distances without the measuring tape. Imagine a scenario where you have to measure a distance which is longer than the available measuring tape. My project can be used in this scenario as well. I solved this problem by using the concept of circumference of a wheel. So as we know, the distance travelled by one rotation of a wheel is equal to the circumference of the wheel. So if we somehow find out the number of rotations of the same wheel, we will be able to find the distance travelled by it, simply by multiplying the number of rotations and the circumference. So this is the prototype for my robot. This is an Arduino Uno, a motor driver, a breadboard, a Bluetooth module and a beeper and a resistor. There are 3 IR sensors, 2 DC motors for the wheels and a LDR. There is also caster wheel. So as you see, all the holes on this wheel are covered except for this one. So when the wheel rotates, the light falls on the LDR once a round. So when the light falls, it counts the number of rotations taken by the wheel. I have also measured the circumference of this wheel, which is 23 centimeters. This tells me the distance covered by the robot. So this is how my prototype works. So now let me show you how my program works. In the program there are 4 variables. The LDR value, to keep track of the value of the LDR if it's facing light or not. The round of wheel value, to keep track of the rotations of the wheel. The distance value, to keep track of the distance and the front tire value, to show the value of the front tire sensor. So now let's have a look at the program. So when I click the green flag, it will send the distance value and the round of wheel value to 0. Inside the forever loop, it will, if the LDR value is greater than 25 or when it is facing light, it will change the round of wheel value by 1 and beep once. Then it will move forward slowly by adding delays, and if the front IR sensor is greater than 50 or when there is a blockage in front of it, it will set the distance value set distance value to round of wheel value into 23. Do you remember that 23 is the circumference of my wheel? Then it will stop the whole program. So this is how my program works. Okay, now let me show you a live demo of my project, which is supposed to measure distance from this line to that wall. It will stop when it faces the wall. Let me start now. The B means that it has completed one round. It has stopped because it is near the wall. The distance is 184 centimeters. It may not be very accurate due to lighting problems. There is too much of light here. There are some ways I want to improve on this project in the future. Like I want to add a few more holes to increase the accuracy of the distance measured, and I want to also make the LDR a bit less sensitive to light. I want to make this car Bluetooth controlled. Thank you for watching my project demo.